different colors conversion, how the computer is going to understand the colors from the time the picture is received to how the colors are going to be given numerical values depending on which color the picture was. So if it was a black and white color, so it's going to be from a light shade to a dark shade. If it's a color, if the picture has colors, it's going to consider three colors. Does anyone remember the three colors, the three main colors that would create the RGB model? Does anyone remember that? Does anyone remember the three colors that will create the RGB model? So when you talk about RGB, which colors create the RGB model?
Red, green, blue.
Yes, red, green, and blue. So with red, green, and blue, we can modify them and create millions of colors. So that's exactly how the computer is going to be working with all these colors. So we have a grayscale conversion. So basically, to facilitate the calculation, what's happening behind the computer is that the colors will be converted into a single channel gray scale image. So in this case, what we're going to have like a maximum value, which will be obtained from the values that we're going to get from the shade of red, shade of green, and shade of blue. And then we can have the mean value and the weighted mean value method as well. So this is exactly how the grayscale image conversion can also be performed directly by invoking the API of the image processing library. That means we can have, as we're coding, we can invoke a library, an external library, which will have colors. So we can invoke that library to make these calculations. So we also have pixel positioning relationships depending on the pixel that we have on the picture and the position that they have. They can have a certain meaning in how the picture is going to be understood by the by the by the computer. All right. So when we have that, we can have a certain connection between this pixel, right, based on the position. So we can have what we call a connection or connectivity of pixel, right? So the connection and connectivity of pixel is, for example, if two pixels are adjacent, okay, and the pixel value meets the similarity criteria. So the two pixels are considered to be connected. All right. So the connections and connectivity of pixel are really the fundamental concept of digital imaging and computer vision. So this will describe how pixel can relate to each other spatially, which directly affect how AI interprets shapes, edges, region, and objects as well. Right. So when we talk about pixel connectivity, this will actually be this will actually define which neighboring pixels are considered connected based on their location, of course. So the location of the pixel, so the pixel will need to be adjacent, okay? And then we also have the similarity. So the similarity means that we have the same colors, same colors or label of segmentation. All right. So two common connectivity type. We have the 4 connectivity and the 8 connectivity. All right. So the 4 connectivity. So this in this case is when 2 pixel, um, uh, for example, pixel P and Q with values V are 4 connected if Q is in the neighborhood of P. So we have that, and then we have the 8 connectivity where 2 pixel P and Q with values from V are 8 connected if Q is in the 8th neighborhood of activity. Will help AI to actually determine which pixel from a continuous object, like the region boundaries, the shape structure, so which pixel have a relationship with another pixel, right? So the 4 connectivity type. So we mean that a pixel is connected only to its up, down, left, and right neighbors. So that is a 4 connectivity pixel. Understand? So when we talk about the 4 connectivity pixel, so it's connected through its ups, down, and left neighbors. So when you're looking at that, um, right? Any question on that? Any question? No question. All right. Um, so now this connectivity, the connectivity 4 is good for when we have this connectivity 4, it's good for to avoid diagonal confusion. So we just have a relationship on top, the bottom, left, and right, right? Um, so and then we have the 8 connectivity. The 8 connectivity include 4 connected diagonally. So we're going to have in the 8, we're going to have this, you see, like this. So in the 4 connectivities, so the pixel has only the relationship with the top, right, left, and the bottom. But in the 8, we're going to also have other day diagonally. There's also a relationship here. So we have a relationship with this pixel here. Like here we have this one here, the relationship between green and so this is an 8 connectivity. So this is only a 4 connectivity. Okay, so and then we can have what we can call an M connectivity. So this is like an hybrid rule, which is used for to ensure certain structures consistency without breaking diagonal shapes. So this can have, like, when we have more complex structure, right? Why these connectivities are very important, it's because of when AI, you're doing certain AI tasks such as object detections, the connectivity will be very important because it's going to ensure that the connected pixel from the shape to create the shape of an object. So the connection between this pixel is very important. All right, so right, so now we have this is how the connection can be done between pixels. So now when we have connected pixel like that, they can create a region. So in an image, if any 2 pixels, right, in a pixel set are connected and they are not connected to pixel outside of that state, right? So the pixel set is called a connected region. So when we have certain pixels that are connected to each other in a certain region, they create what we call a connected region. So a connected region will be classified as well into 4 connected and 8 connected region that will be based on the connection, the connectivity definitions as well. So the boundary of a connected region is also referred as the border or the contour of the region. Okay, so that's how we can have it. Okay, so the next chapter we're going to talk about image pre-processing technologies. All right, so guys, can you still see my screen? Please confirm that. Can you guys still see my screen? Can you guys see my screen?
No, I can't see it. No.
Can you guys can confirm with me as soon as you can see the screen? Is anybody who can see the screen? Can anybody confirm if they can see my screen on the side?
Yes, we can see your screen.
Okay, thank you. All right, so we have now image pre-processing technologies. So when we look at images, before we could process the image, there is a certain process that happened before we can actually deal with the images in our AI tools. So we have image pre-processing. So in the image pre-processing, we're going to have certain steps, right? So the procedure of pre-processing the image. So remember, when we receive an original image, right? We will first need to take that image, and the machine will actually uh, do a feature extraction. Okay, the feature extraction, if we have to do it in the traditional image processing method, which means that let's say you have a picture of um, okay, you want to take people's faces and determine maybe the age of the person based on certain features of the faces. So in a traditional way, you're going to choose what you're going to use on the face as a feature. So maybe you're going to use you're going to look at the eyes or the hair or something like that. Maybe you just look at the color of the hair as a feature or things like that. So that's how you're going to just extract the feature, and then you can do an image analysis and understanding with your AI tool. But if you want to use neural networks, you can take the image that has been pre-processed. As long as the image is good, you don't really need to extract the features, because the 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 the, um, the neural network is going to extract to get the features itself. So can anybody tell us, if we don't select the features, what features are going to be used from a neural network? The neural network is going to look at uh, the information on the picture from each pixel. Remember yesterday we spoke about each pixel will receive a certain numerical number. So those are the features that are going to be used in a neural network. So in traditional image processing algorithm, the image preprocessing will just involve removing irrelevant information from the image, restoring useful real information, right? So, and in image preprocessing, which involve would also involve grayscale transformation, geometric correction, image enhancement, and image filtering. So you need to understand certain images before they can be used in an AI. There needs to be fixed before. Maybe you have a problem with the sizes, you have the pictures in the wrong scale, you have pictures that are not clear enough. So those are part of pre-processing. All right. So we have a grayscale transformation, which means that we're going to be transform the grayscale value. Remember, we spoke about the grayscale value, which is calculated based on either we get a value, an average value based on the RGB model, the values of shades of red, shade of green, and shade of blue get a what you call that, to get the grayscale value. So we're going to get either an average or the maximum depending on what you're trying to get. So now we're going to have that the grayscale value of each point of an image. We're going to place it into a grayscale value based on specific mapping functions. Okay, so and then the transformation is performed independently on the pixel. So the original pixel value is S in this case, and then the mapping function used for transformation is TS. So this is the function which is a function of S. Okay, and then from here now we can obtain the pixel value. Okay. All right, so that is a grayscale transformation. So a grayscale transformation is done, and then we can also do what we call an inversion. So image inversions involve inverting the grayscale value of the original image. So which means that's changing black to white or white to black, and the mapping function will be as follows. So this is the mapping function. This is an example of what the computer is going to do to the image. Okay. All right. So, and then the next one will be image contrast. So all these things, guys, when you are using, let's say you are editing pictures on the if you are editing pictures on the phone, when you look at the picture and then you're moving your phone and everything, like, oh, I'm changing the contrast. So for you, you are just seeing buttons there, but behind those buttons, there is actually some mathematics happening there, and those mathematics are being applied on the picture. This is exactly what we're looking at now. So you have your image contrast. So that is the formula of the contrast there. Okay, so we have the formula of the image contrast here. So the contrast is just the color difference between adjacent pixels. So now you actually understanding the technical side of what we always see, when we looking at an image, we change the contrast. What is the contrast? It's just the color difference between adjacent pixels. Those are pixels that are neighbors. Okay, so this will basically indicate the clarity of an image. So the higher the contrast, the greater the difference between colors. So if the contrast of an image is too high, the image appears very glaring. So the lower the contrast, the smaller the difference between colors. So this is the formula of the contrast. So whenever you see next time the contrast is changing on a picture, you must understand what you are actually doing is you are applying this formula. So you are actually creating a color difference between adjacent pixels. So that's how you can actually fix a picture or completely damage the picture. Okay, so we can have an effect of a contrast stretching, which means that if an image is underexposed or overexposed, its grayscale range is limited to just a narrow range, right? And then the image will just appear blurry or there's lack of details. So when we apply a linear contrast stretching, that can expand the grayscale value of each pixel, and that will improve the image quality. So this is how you can take an image that was kind of blurry and take it into a certain software, and then the image is cleared. Because what the software is doing, it's doing a contrast stretching. Okay. All right. So, so this is an example of contrast stretching. Okay. So this is just a representation of contrast stretching as well. Okay, so this is what it can do to images. So this is by when you keep increasing the contrast, you get to a point where you completely lose the picture. All right. So this is the example when we have the value, the gamma value, like the original picture is here. Maybe the gamma value was that. So because the gamma value there, and then we have it now to 3. So a larger difference between the value of gamma and 1 will just indicate a greater gamma correction strength. So the more we're changing that, the more we are affecting the picture. All right. All right. So the next thing will be the dynamic range adjustment. So this will just refer to when you're having an image, right, a picture. Sometimes the same phone that you have, remember you have the same phone, the same camera, everything is the same, but you don't always get the same pictures because sometimes the lights as well around the image creates the quality, make a certain quality for the picture. So you understand that there's also the light brightness of an image scene. So the scene where the image was, the brightness of the lights, they will also impact everything. All right. So that is what we call a dynamic range adjustment. So we can also actually adjust as well that light to try and improve the quality of the picture. So the impact of the dynamic range on human vision, for example. So human eye can detect only a limited range of grayscale changes. So if a dynamic range is too large, a greater brightness value masks all signals in the dark area. So the dynamic range adjustment rule, so that's mean that we're going to reduce this range to a certain desired area to try and improve the image quality. So you can't just increase or decrease this value of the brightness. You have to reduce it or increase it to a certain range to keep the image quality good. All right, guys. Yeah, I think this will be all for today. We'll pick it up tomorrow. All right, guys. Any question before we can call it a day? Any questions? All right, guys. Yes, I will see you tomorrow. Have a great evening.